All right. So a lot of times, as a matter of fact, I'm going to say always, on a test, you're going to have to write an equation of a parallel or perpendicular line. You do it very similar to how we did it in the prior video. We have to figure out what the slope is. Okay, so we have to find the slope. And then we are going to use point slope formula by plugging in the slope and one of the points that's given. The thing that gives students trouble is that they forget that parallel lines have the same slope. If you recall in section, I think it was 3.4, maybe 3.3, I don't remember, but it's important for you to remember parallel lines have the same slope. Parallel lines have the same slope. Parallel lines have the same slope. Perpendicular lines use negative reciprocal slope. So we're going to use that information to be able to write equations of parallel and perpendicular lines. Step 1, find the slope of the given equation. Find the slope of the parallel line or perpendicular line, depending on what it asks for. Use that slope and the slope that we just found and the given point to put it into point slope form, and then rewrite it, our answer, in either slope-intercept form or standard form. Okay? All right. Find an equation of the line through this point parallel to this line right here. Now, what I'm going to do is I'm going to graph it. No, you do not need to graph it on the test. I'm going to show you the graph so that you understand what's happening kind of behind the scenes, right? A lot of students get confused and think this is the equation of the line, or somehow you have to use this equation when you're writing your equation, and that is not true at all whatsoever. This is not the equation we are looking for. This is not the equation we are looking for, okay? So what we're going to do is we are going to put this in slope-intercept form. So we're going to subtract our 8x. So we have negative 4y is equal to negative 8x plus 16. Divide by negative 4. Y is equal to 2x minus 4. I'm going to graph this. Like I said, this is not necessary to do the problem, but I just want to show you what's happening. So I have my y-intercept is going to be the point 0, negative 4, and my slope is 2 over 1. All right, so this, again, is not the equation we are looking for, okay? Our equation, I'm going to change the colors here. Hold on. Pointer options, ink color, let's use blue. All right, so our equation has to go through the point 2, negative 3. As you can see, based on the graph, this line does not go through this point at all whatsoever. So why do we give you this equation? Because our line, the one we're looking for, is parallel to this one, and it is going to help us find our slope. The blue line, that's what we're looking for. Blue, we're looking for blue. We already have red, we don't want it. We want blue, okay? So to write the equation of the blue line, we need a point and we need the slope. We've got a point, it goes through the point 2, negative 3. We kind of have the slope because we know what the slope of the parallel line is. The slope of the parallel line is 2. Parallel lines have the same slope. So the slope of my line is also going to be 2. Ignore this from now on out. You're not going to use it ever again. Once we use this to find our slope, we don't need it. So we're going to use our point slope formula, y minus our y value, which is negative 3, equals our, equals our slope, which is 2, x minus 2. Subtracting a negative, we have y plus 3. Distribute, so I have 2x minus 4. Subtract 3. And I have y is equal to 2x minus 7. And if I were to extend this line, yeah, I can see how it would hit at -7 down here. We also, so this is our slope-intercept form, y equals 2x minus 7. We also want it in standard form, so we're going to subtract our 2x. -2x plus y is equal to -7, but our x has to be positive, so we're going to multiply by -1, multiply by -1, multiply by -1. 2x minus y is equal to 7. So here is our equation in standard form. Again, I want to remind you, on the test, I'm only going to ask for one of these, not both, but you need practice, so that's why we're doing both. Okay. This time, we want to be perpendicular. All right, so let me change back to, let's go back to red. Okay. So, again, we're going to use the fact that our lines are perpendicular to find the slope for the line that we're looking for. So we're going to subtract our 6x. -3y is equal to -6x plus 3. And we have y is equal to 2x minus 1. So my y-intercept is the point 0, -1. And my slope is 2, so I'm going to go up 2 to the right 1. Once again, this is not the equation we're looking for. Okay? We're going to use the fact that we know the slope of this line to find the slope of our line. They're perpendicular. So, change the color again. Let's do purple this time. Okay, so our line has to go through the point 4, 2. And our line has to have a negative reciprocal slope. So if this is 2, or 2 over 1, -1/2. So it's going to, our purple line is the line that we need the equation for. Purple line is the line we need the equation for. So we've got our slope. It's the negative reciprocal of the perpendicular line, and our point is 4, 2. So we're going to use our point slope form. Y minus 2 is equal to -1/2 x minus 4. So y minus our y value, m, x minus our x value. We want it in slope-intercept form and standard form. Not sure I gave myself enough room. We're going to distribute. Negative times a negative is a positive. You guys know what 1/2 of 4 is, right? And I get y is equal to -1/2 x plus 4, which sure enough, my y-intercept was the 0.04. So this is my slope-intercept form. And now we need it in standard form. So I'm going to add 1/2 x is equal to 4. My x is positive, so I don't need to worry about that, but I do have a fraction. So I'm going to multiply by the least common multiple, which is 2. That should be, oop, I only need one of those. 2. And cancel. X plus 2y is equal to 8. Okay, so here is slope-intercept, and there's standard. Write an equation that fits a data set. Okay, so Some people call this a line of best fit. Some people call this the linear regression line. We are not going to go that deeply into this. What we're going to do is just kind of give the best approximation, and they're going to tell us which points to use to write the equation. So, table lists the average annual cost in dollars of tuition and fees for in-state students at public four-year colleges and universities. And you know this is completely out of date. Okay. Pay attention when it says stuff like this. Year 1 represents 2001. Year 3 represents 2003, and so on. So if I have 11, that would be 2011, right? Okay. So use these 2 points, 3, 7, to write an equation in slope-intercept form that approximates the data of the table. Okay. How well does this equation approximate the costs in 2009? They're asking 2 different questions. First thing you want to do is to write the equation. The second thing they want you to do is use the equation to compare how it actually was. Okay, so writing an equation using real world data doesn't mean it's going to exactly work. And as a matter of fact, as we're going to find, if we plug in 9 to our equation, it's not going to be 70/50. Okay, I'm just giving you a heads up. Okay, so we want to know how close did we come with the equation that we're going to come up with. All right, so which points? We wanted 3 and 7. All right, so 3 and 7. Okay, so we got to write an equation. So we have a point. I'm going to use the smaller point, 3, 46, 45. What we don't have is the slope. Okay, so remember the formula for slope. So we're going to take our second y value, which is 6185, subtract our first y value, 4645, our second x value, which is 7, and our first x value, which is 3. Okay, and I'm going to use a calculator for this. So 6185 subtract 4645 gives us 1540, and 7 subtract 3 is 4. Let's see if it goes in evenly. Does. 385. All right, so our slope, m, is equal to 385. Okay, y minus our y value, 4645, is equal to m, 385, x minus our x value of 3. 4645, we're going to distribute. Let me get 1155. And we're going to add. And I'm going to get out my calculator. 4645, 3490. Okay, so this answered part A. Part B says, how well does this equation work with the actual average, actual data? So we're going to take 9, we're going to plug it in for x. y is equal to 385 times 9 plus 3490. Plug it into our calculator. 385 plus. All right, we ended up with 69.55. Okay, so according to the equation, what the average cost for tuition should have been was $6,955. What it actually was $7,050. So, was it close? It was off by $95. So, I mean, it wasn't really close. It wasn't horribly off, but it wasn't really close either. So I would kind of give this a grade of C as far as how close we were to. It wasn't way off, but it wasn't very exact either. Okay, so yeah.